Hello everybody, in this video we're going to be looking at perpendicular lines. Before we get to the perpendicular line part, let's look through the warm-up. The warm-up says we're going to do the reciprocal of each value. A reciprocal means the flipped version of a fraction, or the flipped version of a number. So whatever number you start with, if you're going to do the reciprocal, then you're going to do 1 divided by that number. If we start with 3, then that's going to become 1 over 3. Negative 10 is going to become 1 over negative 10. 1 divided by 5 is going to make, I'm going to show you what it technically is, and then I'm going to show you the easy version. 1 divided by 1 divided by 5. But you should have learned in the past that whenever you have a fraction divided by a fraction, then that means you keep the first number, you change to multiplication, and you flip the second fraction. And so this makes 5. So in the end, 1 divided by 5 becomes 5 divided by 1 when you do a reciprocal. So if something is already in the fractional form and you're going to do the reciprocal, all you're going to do is flip the numbers around. Go ahead and do these last two, and then I'll show the answers in just a couple seconds. Alright, that's the warm-up to go with perpendicular lines. Hopefully at some point in the past you've learned about parallel lines. And parallel lines are when two lines are going at, I would say, without putting the numbers in it for math, parallel lines are when two lines are going at the same angle. Which also means if they're going at the same angle, then that means that they have the same steepness. So parallel lines have the same angles, which means they're at the same steepness, which also leads to the conclusion that they have the same slope. So anytime you're doing something with parallel lines, you're going to keep the slope the same for those two lines. I do want you to follow along here because it's going to make your geometry lesson next year even easier. The 2 points on this line, point A and point B, and they want us to do a rotation. A 90-degree counterclockwise rotation is going from the top and down and to the left. To do a counterclockwise rotation easily, you could use the formula of you swap the x and the y, and you're going to change the sign of the y. So if our numbers are 0 and 0, then whenever we swap 0 and 0, it stays 0, 0. And whenever we swap the 8 and 5, negative y comma x, that's going to make negative 5 comma 8. Let me put a dot for those so that way you see what it looks like. 90-degree counterclockwise rotation makes negative 5, 8. And then let me connect that down to the bottom line. Now 180-degree rotation. For 180 degrees, that takes the original numbers, and all that it does is it makes them negative. And this is something that you learned in the second 9 weeks of 8th grade. Let me put the point for negative 8, negative 5. 8 to the left, and down 5. And let me connect that to the original. Now 270 degrees. For 270 degrees, it's almost the same thing as the 90-degree rotation. We're going in the same direction, but this time we're just going to rotate farther. And when you do that, that switches the x and the y. But instead of making the y the -1, this one makes the x change its sign. So we do y comma -x, which means whatever we start with, and we're starting with 0, 0, you're going to swap the x and the y, and then you would change the sign of the x, which you'll only be able to see for point B. Then 8, 5 is going to be switched to be 5, 8, and then we're going to change the sign of the x to be a -8. 5, -8. 5 to the right, down 8. All right, I drew that point at 5, -8, and I connected it with a line, and now we have kind of like an x going on in our graph. I'm going to skip question 2 and go to number 3. For number 3, it wants the slope, so it wants m, which means we're going to do y minus y divided by x minus x for that slope. So I'll do point B first for all of these. I'm always going to put point B as my y2 and my x2. We'll start off with 5 minus 0 over 8 minus 0. We get 5/8. For a prime b prime, 8 minus 0 over -5 minus 0 to get 8/5. The next one, -5 minus 0 over -8 minus 0 to get 5/8. And lastly, -8 minus 0 over 5 minus 0 equals -8/5. For the patterns with these slopes, you can see that all the numbers are the same numbers here. It's either a 5 or an 8, but sometimes it's negative, and sometimes there's a 5 on top, and other times there's an 8 on top. So if sometimes there's an 8 on top, and the other times the 8's on the bottom, then the slopes are reciprocals sometimes. And reciprocal slopes is an important concept for perpendicular lines. Perpendicular lines come from whenever you have lines intersecting at 90-degree angles. 90-degree angles means right angles, right angles, right angles, and another right angle. So if you were to find the slope for these lines, A and A prime on the left, or B and B prime on the right, we should get a reciprocal slope. So let's check that. It wants us to explain. And it wants us to write the equation for each line. So we'll do number 1 first. We need 2 points so that we can find the slope in the y-intercept. Lucky for us, in number 1, the y-intercept is 0 each time. B equals 0. So all we have to do is find the slope for A, and then find the slope for A prime. So we'll find the slope for A first by doing 6, 6 minus 2, 2. That gives us 4 over 4, which is 1. So the slope of the regular A is 1. Now let's find the slope of A prime. 2 points. -6, +6. -3, +3. 6 minus 3 for the y's. On the bottom of that fraction, we're going to have the x's, which are -6 minus -3, which means we're going to be adding that bottom number. 6 minus 3 on top makes 3. Negative 6 plus 3 on the bottom makes negative 3, and this reduces to make negative 1. So the slope of A prime is negative 1. Okay, so let's make an equation for number 1. We had y equals mx plus b. So if we put the slope, the first slope was 1 times x, and we said that the y-intercept is 0, and the slope for the second one is y equals negative 1, and the y-intercept was still 0, because they still touch the y-axis at 0. So for the first graph, one of the slopes was positive 1, the other slope was negative 1. I want you to find the slope for the second graph. Find the slopes of regular b and find the slope of b prime. Since this is the second example, I'll pick the points for you. Use this one, 3, 6, 0, 5, and also use 1, 2 with 0, 5. So make your slope fractions and find the answer. I'll show you the answer in just a bit. So pause the video, do it yourself, then check yourself. If you look at the slopes for these two, you'll see that the first time we got 1/3, and the second time we got negative 3 over 1. And those are the same exact numbers, it's just one of them is the flipped version of the other. So for number 2, we have two lines and y equals mx plus b, where the slope is almost the same, but one time it's a reciprocal. So the first time it's 1/3 times x, and the second time it's negative 3 times x. The reason I'm writing negative 3 instead of negative 3 over 1 is because 1 fits into 3 times. So I just reduce that whenever I put the final answer for the slope. On number 2, to finish up that equation, we just need the y-intercepts. And 0, 5 is the y-intercept for both graphs. So that means here for b, we're going to put plus 5 and plus 5. I would like to do a lot more examples with you to show you what happens when you have perpendicular lines, but so far with just these two examples we can see with perpendicular lines, the slopes, one of them is positive and the other one is negative. Even in number 2, one of them is positive and the other one is negative. And the second thing that happens with perpendicular lines is the number for the slope for the line that's perpendicular is always the reciprocal of the original. Let's write this in our journals. If two lines are perpendicular, then their slopes are negative reciprocals. That's super important, needs to go in your journal. Anytime they talk about things being perpendicular, that means the slopes are negative reciprocals, which means one of them is a line going upwards, one of them is a line going downwards. For example, if one line was y equals 3x plus 8, and if that line looked like this, a line perpendicular would have y equals a negative flipped slope to that one. And we can even use the same y-intercept. And these two lines that I just drew are going to have a right angle in between them when they intersect. Take a moment to write that down, and then we'll just do some practice problems.